Hey guys, this is Professor Janacek, and I want to talk about tangent vectors, normal vectors, and binormal vectors when dealing with vector-valued functions. So let's start with a vector-valued function. We'll call it r of t. Now you'll notice I say that this could also be called an oriented curve. What I mean by that is here we have our vector vector r, and notice it has a particular curve direction. It starts at the bottom left and moves up to the top right. It has a direction. So that's what I mean by oriented curve. Now if I take the derivative of that, r prime, we call that a tangent vector. Now we have a special type of tangent vector. Notice if I take r prime and divide it by the magnitude. So I'm dividing out the magnitude, so it turns out the magnitude becomes 1. We call that t, and t is formally known as the unit tangent vector. So we have r prime is just any old tangent vector, but t is the unit tangent vector. Now, if I take the derivative of t and divide it by the magnitude, again, notice I'm taking the derivative and dividing it by its magnitude, so this is also going to be a unit vector. Well, this particular one, which we denote as n, this one is the unit normal vector. And then if we take the cross product of those two, the unit tangent vector and the unit normal vector, we get b, and this is the binormal vector. Now this is also a unit vector, but we don't necessarily need to say that. So let's talk about what those look like. So again, here we have our vector valued function r. It is oriented, going in one particular direction. And then the unit tangent vector, you'll notice, goes in the direction of the curve, so it's still going in the same direction. Here I am going in the same direction. And of course it's only going to be 1 unit long, but it is tangent at that point. Alright, and so that's very similar to the idea of a tangent line. It's just a tangent vector now. It has a direction. What about the unit normal vector? Well, normal implies orthogonal or perpendicular, and so it's going to be perpendicular or orthogonal to the unit tangent vector, but it's always going to be in the direction into the curve, so towards the curve, so the direction of the curve in this case. So that would be our unit normal vector. And finally, the binormal vector, we can determine the direction of that one. Again, it is a unit vector, so its magnitude is also 1, just like the previous two. But what about its direction? Well, its direction we can find by the right-hand rule. For finding direction. So you'll start by placing your right hand, the outer edge of your right hand, the pinky side of your right hand, along the first vector. In this case, our first vector was t, so along t, and then you curl your fingers toward the second vector, so towards n. And that gives you, and then, I'm sorry, I went too far. And then your thumb, so your fingers are along t, and you curl your fingers towards n, and then your thumb gives you the direction of b. In this case, that would be coming straight out of the page at us. So the binormal vector is pointing in the direction towards us. Now really these three vectors help us determine the direction of a curve. So we have the direction of the curve and the direction inside toward the curvature. And so we use these quite often when working with the curvature of vector-valued functions. Enjoy!